Hey everyone, welcome to Pathfinders podcast. Today we have a very special guest, Spider. Let me introduce Spider firsthand. So, with extensive experience in various sectors between consulting, telecom, finance, transportation, manufacturing, mining, pensions, insurance, and education, Spider Campos has excelled in numerous roles within enterprise development for large corporations. These roles include program analyst, system analyst, lead developer, team lead architect, program and technical lead. Technologically, Spider is dedicated to delivering the best possible solutions within resourcing and scheduling constraints. The focus is on developing software that meets requirements, performs efficiently, is secure, flexible, and easily maintainable. Currently, Spider's expertise lies in cloud application development on the Azure platform. From a human perspective, Spider brings a wealth of soft skills, interpretive analysis, communication, negotiation, team building, motivation, and conflict resolution refined over many, many years and numerous projects across diverse industries. This blend of technical prowess and interpersonal skills enables Spider to provide exceptional value to customers, ensuring their needs are comprehensively met and their expectations are always surpassed. He's secretly also a great musician, which we'll try to tap into today. So, Spider, sorry for the earlier technical hiccups. Anyway, so I'm super glad we are doing this again. Thank you for joining us today.
Thank you, Vijay. I'm super happy to be here.
Amazing, man. So, Spider, we want to get to know you, about you a little bit more. Please, can you give your background a little bit, where it started, and give your life background, and then how it all came together?
Yeah, so I was born in Manila, uh, and my family emigrated to Canada in the early 70s. So first in Vancouver, then we ended up in Toronto, and I lived in Toronto. Did my 1 year of high school, went to University of Toronto. Then my family, as a group, drove across Canada to Vancouver. So that's where I ended up, and I ended up graduating at the UBC in applied mathematics and minor in computer science. And then my first job was in 1983.
So, were you always a math kid? I mean, like you picked
Yeah,
actual
math
science.
math
You
was my favorite subject, and I was very good at it.
got
I
it.
had 100%, no, 99.5% average in my final year of high school, and I kept my A's in math at least anyway in the universities. So yeah, like I
You were
looked
a math kid. Yeah.
at the market and like so as a if you want to do mathematics as a career, there's not a lot of options. There's of course teaching, but actuarial science is one what that has mathematics in it, like probability and statistics combined with computer science. So it seemed a logical step for me to take. So I did that. I worked for an actuarial firm called William Mercer, which is one of the largest actuarial companies in the world for in the field of pensions. So there's insurance and there's
Right.
pensions, and I worked in the pensions field as an
And
actuarial.
this is all in Toronto, GTA,
No, this
pretty
was
much.
actually in Vancouver because I graduated from
Vancouver. Okay,
UBC.
got it.
Yeah, so I worked in that field for a while. And so actuarial science is a very kind of elitist kind of field. There's not too many actuaries in the world because it's very difficult to work and write exams every 6 months and to pass all the 10 exams you have to do to get a certification as an actuary. But it
Right.
also has a reputation of being a kind of boring job as a programmer because you're really doing the business domain does not change that much from company to company. So
Right.
you're kind of doing the same thing over and over again. Um, so eventually I got kind of bored of that. Um, and actually I was very enamored with foreign films. And I had this romantic idea of
The
becoming,
creative
yeah,
side of you.
I had this romantic idea. I thought I'd be a filmmaker. So I actually moved to Toronto to with the intention of studying a graduate film at York University. So like a complete career change. Yeah, and I spoke to three deans, including the dean of graduate studies for film studies at York, anyway, the gist of it is they kind of all discourage, like they all told me, if you want a piece of paper, we'll give you that. But if you want to make films, just do it.
Right.
Now, you remember at that time, there was no, in the late 80s, there
No
was no,
YouTube, no social media.
no, there's no Final Cut Pro. These are like, if you want to do your own video editing, right? There's
Yeah.
no Final Cut Pro. There was no Premiere. There was very expensive tools that cost like a couple of $100,000 if you wanted uh, media media composer. I think it cost about 150,000. It was very expensive to do video editing, and everything was still analog. There's no digital recordings and stuff. So anyway, it was very difficult for you to just do your own film stuff, right?
Got it. Got it. Yeah.
Anyway, so I ended up having
And you
cold.
transition into software at
Yeah, well,
around 80s, I suppose.
I
Yeah.
had cold feet, and I ended up going back to actual science for a year, and then I switched to computer science development, software development, in the late 80s.
Got it. And
And
like, what was the push? Like, okay, fine, yeah, actual science, the statistics and math. I'm so done with it. I mean, what was the push like? What was, because I was probably pretty young. And like I'm just trying to imagine what was the period like in the 80s. Like, was there a push for software, or like how did the transition happen?
well, so I know how to code. I knew how to code, and I also found that not being restricted to pensions and having different industries
Right.
uh, is a lot more interesting as a job. And also, I like I said, I had cold feet going into cinema as a career. Um, so as I've worked in software development now, pure software since 89, let's say 88, 89,
Right.
I've traversed so many industries and been exposed to so many worlds. Like I walked into a
Right.
new world every contract, and
Right.
I've met so many interesting people, so many different cultures. So it's been quite an interesting journey from
Yeah.
that point of. So I got rid of all that boring stuff in actual science. Maybe that's not
So,
actual science, yeah, but
so
yeah,
probably name the industry. You've probably already seen it.
yeah,
Um,
I've done a lot.
times over and over again.
Yeah, I've done a lot. So
Got it.
and that was by design. I actually didn't want to just stick into financial or manufacturing or whatever. And I also worked for consulting firms. So I worked
Oh, you did.
for Deloitte, um, uh, PwC, HP, Compaq, when Compaq was still around before HP bought them, and recently for Accenture. So when you're working for consulting firms, you never know where you're going to go and which industry, which vertical
Of
market
course.
you're going to be placed at.
Of course.
So I had a lot of exposure to different, just totally different domains, business domains, and it's really interesting. Makes the job interesting.
Of course.
You-
Yeah.
So.
What was the tech in that time when you got started? And
Oh, okay. So in the 80s, the language de jure at that time was Clipper 5.
right.
So that was an object-oriented computer language. It didn't have the separation between
Right.
front end, middle tier, and back end.
Right.
But it was object-oriented. You could, do inheritance and polymorphism, and but it was only for text-based systems, not visual systems. Yeah. So and then I got into Fox Pro, which did have a Windows UI to it.
Right.
But yeah, and it was I worked in that space for a few years, and then switched over to the Microsoft world.
Visual
First
Basic and stuff.
with
Okay.
Visual Basic, and then I just moved into the .NET world with C Sharp, right? So
Yeah. Yeah. No, I remember like because like I would imagine, because when I got started, the first program I ever wrote was probably in 2000, and that's when I created my first website. And by the time you have already probably crossed general like corporations, you're already delivering software for them. And like I always used to wonder how was the period of Y2K, and and the software engineers working during the 80s and 90s, the Y2K was a huge conversation around that period.
Yeah.
Can you talk about the Y2K experience that you
Yeah.
went through?
Yeah, that was there was whole paranoia of airplanes falling from the sky, and the
The grid
the
lockdown and
good luck. Yeah, power things would shut off, and nuclear systems would be activated. That didn't happen. However, it was real that there was quite a lot of work to identify the systems that needed to be moved from 2 to 4 digits for the year.
right,
Um, so that there was a lot of work at that time for sure, just fixing stuff that to accommodate 4 digits for the year. Um, but I guess in the end, I don't think all the work got done.
right.
But somehow the planes didn't drop. The power grid was okay.
Yeah.
Um, so yeah,
So what did we do? I mean, did we apply patches? Did we apply hot fixes for the products? Like,
oh,
I knew the problem existed and suddenly disappeared all of a sudden. Like,
no, it's not. It required a lot of thought and analysis to
right,
to, to identify the areas that required fixing, and these are not quick fixes by any way,
right,
any
of course,
stretch of imagination. So the
right,
fixes occur. I mean, they commenced at least a couple of years before the 1999. There was work done, analytic work at the very least,
right,
initiated at least a couple of years ahead, and then you implement it, right?
right.
So it wasn't off the cuff
Got it,
fixing, right? You,
got it,
you, you can't do that otherwise. There's just so much to understand. Analysis work before even the coding change could happen.
got it.
Obviously databases. When you store the 2 characters for a year, now they have to
Yeah,
be 4 characters or whatever. So
yeah.
yeah, there are a lot of that stuff that
Got it.
changed.
No, very interesting time period. And then what happened? I know you did a. I mean, before getting into the microservices world, the cloud world. How was the early 2000s, and how was that period for you?
Well, actually, I got into the .NET era in 2001, I believe, so fairly early on. I think when .NET 1.0 or 1.1 was released, then I joined that world. Uh, First as VB.NET, and then I switched pretty quickly to C Sharp. Um,
Right.
uh, and the language is a lot more elegant and a lot more compact and
Yeah.
succinct. So yeah, so I made that switch then, and never looked back. I mean, the language itself was great, but the architecturally, the idea of splitting into tiers was new at that time for me, anyways. Because
Right.
in Clipper 5, kind of everything was all layers were in one. So the
Right.
idea of having a 3-tier architecture was new to me.
Right.
To separate the front end from your business logic from your back end. Yeah. So
Yeah.
um, that was kind of a revelation. And then, of course, things are configurable. Like you can configure things.
Yeah.
Uh, and
And then and two things that always stood out, and at least a question for me, and I'm sure many of the tech enthusiasts have it. One was the monolith, right? I mean, like you have a user interface, and you have a business layer, and you have a database. It's all like stacked upon, like it's a monolith, right? So
yeah,
that's how it was for a long time. That was one question, and the other question was about the centralization of software, which we can get into in a few minutes. But like, well, what I mean, now we are trying to
right.
separate it, modularize it, and
Yeah,
then
yeah.
trying to separate it. Why did it not was it a thought? Like, why was it a monolith in first place?
Uh, I think
Was there ever a conversation to separate it? And
no, I
and now we know we have cloud like microservices, and like
yeah,
we separate it,
like
modularize it.
like even in the beginning, like a lot of stuff was desktop applications, right? They were
Right,
just on your desktop. You never went to a server to. I mean, you might all the logic was in your drive. You installed the software on your local machine, and
right,
then you just sent the data over or got the data over from maybe a centralized database, right? But
right,
the, the business logic, the middle tier didn't exist. I mean, it did, but it's on your laptop, right?
Right.
So yeah, certainly the advent of websites to handle business logic as well as UI was,
Right.
very new to me at that time. It was very novel. I mean, obviously today this is the way you do things, but yeah, I think the reason why monoliths were, I mean, it was a transition, right? We went from like procedural programming to object-oriented programming. Um,
Right.
and
Right.
there's been a number of paradigms since then, like domain-driven design and so forth. We're going to talk about that.
Got it. Got it.
But I think
And
that it's because why was it that way? It was the easiest thing to do. I think,
we put it all in
you,
a box.
yeah, put it all in one stuff, and yeah. I mean, there is a cost to modularization.
Right. Of
You
course.
and we'll talk about that. But you have to synchronize your information across distributed systems. So there's a cost to that, but
And
the benefits far outweigh the cost, of course. Otherwise, we wouldn't be doing it. So
of
yeah,
course.
so people did the easiest possible thing, I think, at the time.
Yeah.
Uh, so monolith
It's
was it, right?
yeah.
And also, here's the real pressures, EJ. Your manager goes to you as a developer and says, I want this done, right?
Yeah.
And so at a certain, and usually yesterday, right? So
Yeah.
so what do you do? Like, even if there's, let's say, a new paradigm came along, right?
Yeah.
Unless there's will from technical management to
Right.
implement a new better architecture,
Right.
developers are going to do the fastest way to achieve the deliverable, right?
Correct.
Because
Correct.
they're just on, okay, how quickly can you deliver it? Oh, that guy must be good, right? Because he
Right.
delivered it quickly. But the business is unaware of what's underneath that delivery. Is it
True.
maintainable? Is it flexible?
Yeah.
All of these things, they don't see it. They don't know any of that stuff, right? They just
Yeah.
know, okay, this guy or this woman delivered it at this time. He's good or
Yeah.
she's good.
Yeah.
But that's
Yeah.
that's a
It's
problem.
all about getting shit done. So I mean, like the value attached to like how is it done and like why is it done in a certain way was
Yeah,
less than actually getting it done, right? So
exactly.
I felt that
And you know
pressure.
what,
Yeah.
DJ? That's still true.
That-
That's still true today. There's always going to be uh,
yeah.
this in the interest of business against the interest of IT, even though it's actually in their interest as well to build software in a particular way that may
Right.
take a little longer, but
Yeah.
it's in their interest because that's how we ended up with a monolith. Like I
Yeah.
work in I work for a corporation today that the software was built many years ago,
Yeah.
and it connects to a mainframe, some water cooled mainframe with some machine,
Yeah. Yeah. Yeah.
and their software still runs today. I mean, they can build various layers on top of it, but in the end, they make a call to a mainframe COBOL program
Yeah.
to this mainframe in some water cooled room somewhere.
Yeah. I,
Um, yeah,
I remember. I remember. I mean, like when we were writing an adapter for a mainframe, and I think I was leading the architecture at the time for a State Department. I would not call out the name of the State Department, but like it was a State Department in the U.S. at the time, and I think we were. It was all mainframe, and we were trying to write a wrapper,
right.
and around the mainframe, and everything until it hit the mainframe, it was okay. But once you hit the mainframe, you had absolutely no control, and
Right.
like it's like there are only so many things you can execute at a time, and like right, it is
Yeah.
so
Yeah.
uh, I wouldn't say backwards, but at the same time, it was so linear and very different in a way how it is engineered actually. But anyway, so
Yes.
that's what
And that's
mainframe. But still, banks run it. Still, many of the DMVs
yeah.
still run mainframe.
Right. Absolutely. And it's a risk, right? As a manager, as a vice president, let's say, it is a risk for you to take the step. Let's say you say, you know what, I think this mainframe is like killing us.
Right.
Let's have a plan to cut off our dependence on this thing.
Yeah.
It's a huge risk on your career to do
It
this,
is. It
and
is.
with a large risk of failure.
Yeah.
So most often, management, upper management wouldn't take that risk on their careers,
Yeah.
because if they fail, they're gone, right? And
And I asked this question. I mean, like normally they are like really senior developers, really thoughtful people. They know what they're doing. They know the COBOL language that they're writing. And I asked them like, why are we not transitioning to something modern? And they laugh. Maybe I think it probably it is laughable. I guess
yeah,
but probably because they don't seem to see the trust or the performance in modern languages. Like, for example, none of this seems to be attractive. Cloud or microservices or like scalable design. Nothing seems to be so attractive. Uh, and for folks who are in the mainframe world, they say no, nothing can beat the security and the performance of what we do at mainframe.
yeah,
So if you want to have a leaky design, something that is less secure, yeah, go for it. That's what I've heard at least. Like,
yeah, yeah, yeah.
yeah, I don't know if yeah. So I think it's probably going to take a while to transition it to really super secure systems. One other question I had, I don't know, this is something, I mean, being in the software, and I think tech is actually trying to do different things. And then, of course, there are like large entities and corporations that have basically evolved over periods of time. And when the corporation grows to enormous sizes, and of course, there are thousands and thousands and millions of people using it. And also, there's a problem, huge problem with centralization, right? I mean, like centralization is also a problem because, like, either it works or it doesn't, because there is centralization, not just the centralization of authority, but at the same centralization of like decision making, where we keep our data in terms of like centralized databases, centralized servers, etc. Right? I mean, why was there ever a conversation of decentralizing it in the 80s and the 90s era? Because like I remember around the financial crisis that happened around 07, 08, and after that,
Right.
and only after that, so conversations about decentralization and Bitcoin started evolving, which seemed to be a huge conversation in these days. Everyone thought it's going to go to zero. It's, I think, probably the last I saw, it's probably like $70,000. Keeping the monetary part aside, putting the focus back on tech. I think decentralization is an amazing concept. Was that ever a discussion during the 80s and 90s at all, Spider?
You know, in fact, in fact, everybody wanted to have this concept of a tombstone information, yeah, and everything was you had a centralized database which might have been replicated, but it's still the same database. Uh,
Right,
so you're writing information, and then you have some sort of mechanism that replicates to various instances of your database,
right,
or mirrors of your database across regions, let's say across the world. Yeah. So this is
right,
one way of optimization. But so yeah, and then in 1993, uh, a brilliant computer genius, really, named Eric Evans, came with the concept of domain-driven design. And to me, that is as important as object-oriented programming. It's really an incredible paradigm
right,
that solves a lot of problems of with centralization. It allows autonomy of development from a business perspective and from a team development perspective. Uh,
right,
and it allows for like I say, autonomous development and parallel development, and without stepping on each other's toes.
right.
And from a resilience point of view, if one of your services go down in one domain, it doesn't
Yeah,
affect some other domain. Because
right,
so yeah, but this is a now that was 1993 was invented, but I can tell you that for a lot of major organizations, they've only started picking it up in the last few years. Like it takes like 20 years for this thing to catch on, at
got
least.
it.
It's already actually uh, maybe is it 30 years now? Yes, it is. It is 30 years now.
Got it. Got it. I mean, yeah, no, no, glad you brought the topic of like domain-driven design. I think we'll be diving deeper in some of the associated concepts. I mean, for an average person who is not like extremely into the tech world, I mean, can you give like a two-liner of like why DDD is super important, like a domain-driven design, and why that is organizations are paying attention to it now more than ever.
Yeah. So the idea behind it is that when they talk about domain, they mean business domain.
Right.
Um, so what you're trying to do is getting away from the monolith, right? You divide your business up into specific business subdomains, basically, and then you do development within those domains, and then you communicate between those domains asynchronously. But within the domain, so your everything that you need should be in that domain in order to do the, any business processes you have for that domain. So
Right.
you will have your own database with your own data that is
Right.
only uh, germane to your business domain and nothing else.
Right.
And then what happens is if when you perform certain uh, processes, you publish uh, an event
Right.
to some message hub. And
Yeah.
why do you do this? This is a way of you informing other business domains that something happened in your domain, and
Got it.
this gives other domains an opportunity to consume your event and
Right.
make any internal changes to their domains should they choose that. And
Got it.
that way, and then they would update their own data, internal database. Some other domain is going to update their internal database. Should they choose to use it, should they
Yeah.
decide that the event you published is
Yeah.
something they want to incorporate in their domain. But you can see that it's asynchronous. You're not making, so this domain doesn't make a call to another domain to grab some data or put some data in.
Got it.
No, all the data that it needs is in its domain, and then when it does something, publish an event saying, "Hey, world, this is what I did,"
Yeah.
and then all the other domains can be listening to message hubs and captures that domain, that event that you published, and
Right.
then they can decide for themselves whether they want to incorporate in their domain or not.
And this concept can be applied to like any industry, any business domain, right? I mean,
Yes,
let's say we pick an example of manufacturing domain, for instance. So
yes,
manufacturing is going to
yeah,
have like manufacturing equipment, raw materials and stuff. There's
yeah.
going to be employee staff, there's going to be shipping, right? Different departments. So if you had to like apply this DDD to a manufacturing context, like how would you
Well,
uh
let me talk to you about one of the main stumbling points that managers always have to get to wrap their head around.
right,
Like most businesses would like this idea concept of a customer, let's say the customer,
right,
and they always say, well, we can only have one customer for all our domains,
right,
and that's a problem
yeah,
because in fact, a customer and the needs of a customer in your domain will differ from another person's from another domain.
right,
So, for example, from a billing department, you're interested in collecting money. Yeah,
right,
that's what you care about from the customer. Did they pay?
yeah,
How much do they owe? But so those are the attributes of a customer that you're interested in. Maybe their bank account number that they make payments through.
yeah,
But from a shipping department, they don't care about any of that stuff. They care about your address that they're going to ship to, when they're going
right,
to ship the stuff to. That's the information they need from a customer, uh,
right,
and they don't need all that other stuff from a billing perspective. Yeah. So
right,
the attributes of a customer change wildly from one domain to the other. So this idea of having a centralized customer
right,
is one of the most difficult stumbling blocks for managers to get to let go of,
yeah,
right? So because common attributes about a customer, it can be communicated between domains via
yeah,
this messaging mechanism we talked about earlier. I
yeah,
changed the customer's address in my domain. I'm going to publish, hey, this
yeah,
customer, his address changed.
yeah,
You publish it, and some other domain picks it up and says, "Oh, okay, I better update my address with this new address that came in, right?
Yeah.
So that's just an example. So the truth of the matter is that the tombstone information, it doesn't, in the domain driven design, it doesn't exist, because uh, I give this great analogy, VJ, to I was trying to explain this to an architect. I said, you know what? When I work with you, uh, I work with you as an architect. I worked with you as an architect in my previous job. So I know VJ and I know his architectural skills, and we talk about domain driven design among many other architectural patterns. But I know that when VJ goes home and his wife greets him, his wife doesn't care about domain driven design or any architectural pattern.
That's probably the last thing that.
That's what I say. His wife cares about, honey, did you bring the money home? you know,
Yeah, West
uh,
Honey was the.
you know what I mean? Like
Yeah, I
she's interested in your function as a husband and as a father. And your kids greet you and say, "Hi, daddy, daddy, let's play." They certainly don't care about did daddy bring the money home. They don't care about. They just care. I want to play with daddy,
they
and
don't
I
care
want
about
my.
DDD.
I don't, just
They care about
I
daddy.
want my
Yeah,
video game, my new video game, daddy. Uh,
yeah.
so so what I'm saying is there's no one VJ. There's actually multiple versions of VJ, and
100%.
they are all simultaneously real.
Yeah,
Uh, so the fact that this notion that there's one customer, that there's one VJ, is totally fallacious. It doesn't exist because, like I said, I've just proven to you.
it's multifaceted. I mean, there are
Yeah,
multiple faces to
yeah.
of each entity, each individual.
And yet we write our software as if there was only one, but
Yeah,
that was broken with domain driven design.
right,
That was shattered, and that's the brilliance that Evans brought
right.
to the world. To don't pretend that there's that this one version or one monolithic version of a very complex individual named VJ, right? So that's what I
I'm
want
not,
to.
but anyway, but
No, but
yeah,
I
but
mean,
I
it's
hear you. Yeah, yeah, I
yeah,
hear you. Yeah,
that so you can use that analogy. Like their
true.
interest. Like if you ask your son, your 5-year-old son, if I asked him, "Hey, what's your dad's name?" What's he gonna say? Daddy.
Yeah,
He's not gonna say VJ. So even name, from his perspective,
it's
this
very different.
entity called VJ's last name is Daddy.
Right.
It's not VJ.
Yeah,
Yeah. So
yeah.
I can. So everybody thinks, okay, well, the name should be universal across domains, but it's not.
It's
It's
not. It's
not.
not. It's not. It's no. It's very interesting. I mean, your siblings might call you something else.
That's right.
Your right.
Yeah.
Your mom and dad are going to call you something else. Hey,
Yeah.
son. Right.
Yeah.
I mean, like, yeah, absolutely, absolutely. So now interpret now bring the DDD on top of this analogy, if you could again.
Yeah. So by looking at the inputs, the entities that and the processes that are in your domain, you're only interested in particular aspects of uh, like the customer, depending on which department you're working, right?
Right.
So you don't care about all that other information, and you shouldn't. So in your domain, if you're in the billing domain or the shipping domain, you will only have attributes saved in your database that's relevant to your business process and nothing more.
Got
The
it.
other stuff you don't care about. So that actually makes your database a little bit more compact and
Right.
tailor made to your business process.
Got it.
Okay. And it doesn't mean that what you do stays in your world only, because
Got it.
you have this publishing mechanism where you publish an event to external message hubs. And that's how you communicate indirectly with other domains.
Got it.
That's how they find out and vice versa. That's how you learn about what other domains are doing.
Got
Yeah.
it. Got it. So before we, I mean, of course, we want to chat about event sourcing and vertical slicing. Before we segue into that, I mean, there's we wanted to touch upon CQRs a little bit so that
Yeah,
like
yeah. So
people understand
yeah,
publishing messages and stuff like that. So that like, can we touch CQRs maybe then go to vertical slicing if that's
sure,
okay?
sure.
Okay,
TQRS, command query responsibility segregation. It's a
right,
mouthful, so that's why everybody just calls it TQRS.
right,
So what it means is you're going to separate basically your reads from your writes. Although I would caution that that's a bit um, simplistic, but you can look at it that way. And the reason is because there could be different demands for your read services from your write services. For example, if you have a website that has that a lot of people are browsing, right?
Mm,
So you need to give them information uh, much more than buy. Let's say they want to buy something, but you go to Amazon, you spend most of your time browsing for stuff, and
right,
then every so often you buy something, right? So the read demands are so much higher than the write uh, demands. Yeah.
yeah,
By writing, I mean that's when you actually go and buy something.
of
So
course, yeah,
when you do that, that means they have to write that information, the items you ordered,
right,
what you paid, when
of
they're going
course,
to deliver it, and all of that stuff, right? Those are right operations. When you're browsing, you're just okay. You have a shopping cart. It's true that they do a little bit of writing, and that in fact that might be just staying in the front end in your browser. It
right,
might never go back to the server to accumulate the items that you put in your shopping cart. But regardless, that's the majority of your activity will be more browsing until you actually commit to buying something. Yeah. So that
right,
means that you need more services, resources dedicated to read services rather than write services.
right.
Because
HTTP gets and yeah,
yeah, so much more of your activity, the customer's activity is spent browsing than
right,
buying.
right,
So then you can allocate that's why you want to separate your services into command C, that's
yeah,
the write service, and Q, that's the read service.
the
You're
query,
separating the instances of your service,
right,
and when you can separate instances, you can scale them separately rather than scaling them in the same way. But they're not, almost never not. I
right,
actually in our last job actually I heard that they had the opposite problem. They needed more write operations than read operations,
right,
and this was because it's like a license renewal system, and there were more people don't go browsing for items to buy. They just they just want to because they just want their driver's license renewed. Yeah,
yeah,
so
yeah, yeah,
there
right,
was more write demands than read. So they had the opposite situation. They had to
right,
allocate more resources to write services than read services. Yeah. So
gotcha,
CQRS gives you that flexibility
right,
of scaling based on customer demand. Yeah.
got
Okay.
it.
So yeah. So that's CQRS in a nutshell. Yeah.
Got it. Got it. No, that's fantastic. So that brings us to the
Oh,
topic of like
I should also,
sorry, go ahead.
I forget to mention that not just from allocating resources, but you can write your code to be more efficient for read operations. So
Right,
versus write operations. If your backend database is a relational database,
right,
so when you're doing a write operation, you might have it so you're writing to normalized tables. That means you're writing to multiple tables all the time
right,
and keeping that third normal form at least and
right.
higher uh, to for data integrity and so forth. Yeah. Uh,
Got it.
but when you're reading, you want speed.
Yeah,
So you would optimize your read operations and your read services to denormalize tables. That means you're cutting down your joins, the number of joins,
right.
so that the if at best case scenario they'll only access one table that might have repetitive data in it, but
Yeah,
storage is cheap nowadays. So the cost of joining is going to slow down your system, and since storage is very cheap nowadays, you don't
yeah.
mind having duplicate data per row if it means cutting down on having to join information. Just hitting one table, get all your information. That
Got it.
optimizes your speed of retrieval and returning the information to the customer. So
Got it.
not only in terms of allocating resources in instances, but also how you would code your stuff differs
Yeah.
from whether you're read or write operation.
So I mean, like, uh, maybe in paraphrasing, I mean, like, from a DDD and CQRs, I mean, two very interesting concepts. DDD, we are trying to segregate from a domain point of view, and, like, let's say if you're in the marketplace, or if you're basically at a retail store, for instance. A retail, the way we do things at retail store is very different than how we do it in an online marketplace, right? It's very
Yeah,
different. And bringing back the CQRs, I mean, there you're the same example of Amazon. If you're probably spending more time in your website or in your app, you're going through the different products. So we are basically searching through all this information, finally make a decision, and then we place an order. So orders are basically the commits that basically they get processed
right,
in the warehouse and things like
right.
that. So DDD is one level of segregation from a business point of view. It's at multiple level, and CQRs is also a sub segregation within a
Yeah,
domain, if we can
yes,
put it right.
yes,
So
exactly.
it's
Yes,
all e-commerce anyway, and it's online e-commerce probably is the larger domain, but at the same time, when you go it, it's like browsing and actually placing an order. These are two sub,
yes,
reading and writing is a
yes,
sub part of the domain, right?
yes, yes. Exactly, exactly.
Got it. Got it. No, no, that's amazing. So if you're good to transition into event sourcing a little bit, I know
No, no.
you
Let's
wrote.
start with vertical slicing because so vertical
Got it. Let's
slicing,
cover vertical slicing. Yeah.
yeah. So vertical slicing, I think that was championed by a fellow named Jimmy Bogart, who has written, I think, will be quite familiar to a lot of developers. He wrote AutoMapper. He also wrote Mediator, which millions, tens of millions of developers use throughout the world. So he's a heavyweight guy. And he's a big champion of vertical slice architecture. I mean, you can go to Jimmy Bogart's site to Google about vertical slice, but essentially, it's kind of went away from the clean architecture, um, like the onion architecture that inside you have your business domain, uh, and then you've got your application layer outside. And then at the very outside layer, you've got your infrastructure with the idea that you can change the concrete implementations of things without disturbing the inner part of the onion. Um, so Jimmy Bogart champions the idea of a vertical slice, which means you're gonna have uh, everything that you need. You're gonna basically be coding by feature. Everything that you need for a particular feature is sitting in one folder. So your API call, your yeah, that's him, brilliant guy. Your application layer, your uh, domain layer. Um, so that you've got the API, your the, application, your domain layer, and then your infrastructure layer. So they could all be sitting in one folder so that if you want to get rid of a particular feature, you can just delete that folder. It allows for autonomous development by different teams. So you can give one feature to one team, and they don't have to touch, uh, for example, the same code that somebody else's works in because you're not grouping by uh, like you're not touching the same code for a domain because you're looking only at the business for that feature. You're not putting a bunch of features domain code into one domain class. No, you're going to have multiple domain classes, and that domain class only has business logic for that one feature. Like
Yeah.
placing an order, your domain class will only have the business logic for just placing an order. And then canceling an order, that's another feature, another use case. Your domain class only has business logic on canceling an order. Okay, oh, I need to check whether the order was placed within the last month. Afterwards, they can't cancel their order because it's expired. So that logic would be in your cancel order domain. You're placing an order, it's different. You wouldn't have that there, right? So you wouldn't put that business logic in the placing an order domain. So um, uh,
Got it.
and it's a very appealing way of writing software. There are many advantages that you can read it on its site, but I'm a big believer in it with one difference. I don't put the infrastructure layer in the vertical slice itself because I believe the infrastructure layer should be in your component library. And I'll talk about that later. The infrastructure layer for me shouldn't be in the vertical slice itself. It should you be in your component library that's common to all vertical slices. It's a plumbing tool that will
Right.
do your retrieval and your saving your application. You can configure them to be because you're using generics. You use generics,
Right.
you use dependency injection,
Right.
and you use configuration in order for those interfaces that are defined um, in your feature folder, in your vertical slice, to resolve to a concrete class in your component library. But the concrete class itself is not found in your vertical slice folder. It's in your component library. That's
Got it.
the one thing I little wrinkle I do.
I mean, I'm just gonna, uh, coming from the world of Clipper 5 and Visual Basic and .NET and J2E and Java, and we have seen software and software development and software engineering evolve over a period of time, and and of course Jimmy Bogart pioneered the vertical slice way of doing it, and now of course there's going to be a question of why it has to be vertically sliced. I mean, why is there even a reason to uh, approach this way
I
in
would
software?
say that for me, the most appealing aspect of it is autonomy, independence of development, and parallel development. And you don't touch each other's code. You your domain class is your business logic for your domain is not found in a single domain class. When I wrote some software for a transportation company, a big one in Ontario, uh, I didn't do vertical slice. So all my business logic was in one domain class. This would that looked after the all the different processes in one class. So it was quite bloated,
A heavy class, a
heavy,
big
heavy,
one.
heavy. Exactly, heavy, heavy. So when vertical slice, when I became aware of it, I'm going, holy crap! I could have written that class, that I could have broken that domain class into
Right.
multiple domain class. And in fact, I could have it so uh, discrete so that
Yeah.
the domain class can only, so granular, that's what I wanted to
Yeah.
say, so
Yeah.
granular that it would only have the logic for one feature, just
Yeah.
one feature. I want to cancel a trip. I
Yeah.
want to cancel a train trip.
Yeah. Yeah.
I want to redirect the train to go to some other track
Yeah.
rather than this track. That's for that domain and that domain only,
Yeah.
or for that feature and that vertical slice only. I would
Yeah.
have a domain class that
Yeah.
only had logic, business logic for that feature,
Yeah.
for that vertical slice.
No, this
Yeah,
is it's so funny. I mean, like every time when it reminds me of earlier times when I was learning computer science much before engineering it, and it's there's always an example analogy of a car. I mean, when they're trying to explain the concept of a class, right? I mean,
yeah, yeah,
imagine there's a car and there's a tire and there's an engine and there's a mirrors, right? Each entity is basically a class by itself. Now with vertical slicing, what we're talking about, even a tire by itself, if tire is a class and we are breaking the class itself into sub, okay, you're inflating the tire, you're deflating it, and there's probably a tube inside it. So each of these sub features of a tire
yes.
makes its own
Vertical slice.
vertical slice, right?
Yeah, you're dividing it by the functionality that it's going to provide to the to the business. Yeah, you're dividing
Right.
it and you're writing software that very much I would say that vertical slice architecture is like service oriented done right. Like it's really
Nice way to
broken
put it.
down so granular that even if you change your the logic in your domain, you're not going to step on somebody else's business logic in
Right.
their feature, in their vertical
Right.
slice.
Right.
So because you're not actually touching the same code, it's
Yep.
separate code. So
Yep.
this mitigates against, you know,
Yeah.
screwing up somebody else's code, right?
Yeah. Even if you're just responsible for a couple of methods, you can just be doing your own thing, and without like disturbing 10 other people, right?
Exactly.
So
And you
yeah,
can
yeah. And
and you can
maintaining it,
yeah,
maintaining the nightmare of maintaining it is
exactly.
almost gone.
Yes, yes.
Yeah.
And you can assign one team to do this feature, and you don't care, you don't worry that they're going to step on some other person's work on some other feature,
Right.
because they're not going to have the same domain, right?
Yeah. Yeah.
So
No.
yeah, so
No.
that it's,
That's
it's
amazing.
very, very appealing in that way. So like, there are people who are think the onion principle and clean architecture is like the holy grail, but I don't think so. For me, vertical slice is the way to go versus the onion way of writing software.
Got it.
I,
Got it.
yeah, and like I said, with one exception, I truly like what I've done for the component library that my organization has developed. We put the infrastructure class not inside the vertical slice. It goes in your component library, and you can use generics, um, right? Generics and configuration and dependency injection to be able to your component library to serve multiple features. And that's the idea behind a general purpose library that can be tailored to all sorts of things. If you can configure it, if you can use generics, if you can, what was it? I said those three things I said: generics,
Dependency injection.
dependency injection. Yes,
Yeah.
this is how you can achieve your infrastructure to be in a common component library to service multiple vertical slices.
Got it. Got it.
Yeah.
So that takes us to the conversation of event sourcing. I think that's a
Yes.
library that you have
Okay.
come up with.
No. So no.
Why don't you take us into that? Yeah.
Yeah. So event sourcing was invented by Greg Young fairly recently. I think it's probably the newest of all the architectures that we've been talking about, and to me, it's just phenomenal because it made me realize that I've been writing software wrong, incorrectly for most of my career, because the way systems are written is they only yes, there he is, Greg Young, handsome fellow he is, um another genius. And the reason is because systems are written, and they still are written, where they're only saving the current state. So they're just saving. You do some operation, you go and you write, modify or add a record or delete a record into your table, or if you use an object-oriented database, your entity, you might replace an entity or delete an entity, or modify it. And you just save the current state of it. But you have no, if you just look at that table, or that container, if you're using object-oriented database like Cosmos, you have no idea how did that how did that thing get to its current state. Now you might say, well, no, I have an audit trail, right? I have an audit log. The problem with that is your audit log only tells you uh, data data change, not domain change. It can only tell you insert, update, deleted. It
Yeah.
can't tell you why it was updated. What business process was responsible for making this change? And not only that, how many other tables were changed because of that business process? I mean, all
Right.
you know is this one table changed, but then you got to go searching for other tables that might have changed
Right.
as a result of the execution of that business process, right?
Right.
So
Right.
you lose. So in other words, you lose business context. The way we're writing software right now, you lose the business context of how you got to your current state. You don't know what occurred uh, to trigger a bunch of changes. Audit trail is very, very limited. It doesn't tell you.
Audit trail to me, it's like very uh, elementary in terms of like what happened, like a
Yeah,
history of what
yeah.
what happened. And if you were to look at audit trailing, you're probably not getting anything. You're just getting a bunch of logs. Uh,
You're getting to know what data changed.
yeah,
But more important than data is domain.
yeah,
What was the domain process that was
yeah.
executed?
You don't get the context, full
You don't get
context.
that. You don't get the domain context, the business context. So domain-driven design. So here's the thing, and I wrote me and my partner wrote an article on Medium.com. Where, by the way, here's a cheap plugin. If you Google Medium.com and put vertical event sourcing, that's the term we coined for our component library. Vertical event sourcing. You'll see. Um, so
Please, can you help me here with the
so it's
search?
it's Medium. Put Medium.com and then vertical event sourcing. Yeah, that's
Is
it. The
it
first one.
this one?
Yes, yes. So we wrote a series of articles explaining um, the stuff I'm telling you right now. So actually, most of us already know vertical event sourcing. If you open your bank account in your branch, in your online, right? You go online, you go to your bank, you see a series of transactions. What came your
Yeah,
debits and credits, right? So okay, for July, you know, I got a bill come out on the first, or I got paid on the first, and then a couple of days later I got a bill from Hydro,
yeah.
and then I took out some money for groceries, and then each line at the end of the line on each right hand side you see balance,
Right,
right? Balance is your current state. Each one of those transactions are the events that occurred. What happened? What happened? Yeah, I start this article out in a very kind of humorous way, and it's saying like, what is history? History isn't what happened. History is what we recorded that said what happened. Like I
yeah,
mean,
yeah,
stuff was written in the Bible. Let's say if you were, or in the Quran, people wrote stuff down, right? I mean, was that what happened? We don't know, but what people wrote down, we claim that's what actually happened. It's the record that's the source of truth. So effectively, the events are your source of truth, not the current state. The thing with event sourcing is each event is your source of the log of your events over time is
right,
what is your source of truth, not the current state. You can derive the state. In fact, you can derive the state of your system at any point in time in history by replaying the events. Like for example, if you wanted to know what what was your balance in your corporation, VJ, last
yeah,
year, you wanted to know your financial what happened as of what was your closing balance
yeah.
you go back into your bank account and you can see the
That's a
transaction.
ledger, right? Yeah, of course.
There
Yeah,
is, right, because accounting systems for the entire existence was built on the idea that the events are the source of truth, not the current state. And yet, what do we do in our software? We've been writing current state software for decades, and we still do it,
right.
right? We don't write things like capture the event
Yeah.
and derive your state from the events. I call them state views, right? So state
Can
views,
I? Yeah, sorry. Go ahead. Go ahead. Go ahead.
I just
I had
going
a question.
state.
I'll ask you after
Yeah,
you finish. Yeah.
state views are not just used for like, yeah, you could use them for reporting or for displaying something on the screen. But state views can be used for business decisions as well, uh, or business validation. Like for example, you have a bunch of events. You placed an order, and then a few days later, the customer wants to cancel the order. Well, in order to do that, you need to know uh, when the uh, order was first placed, right? So you could go find the state view. Okay, when was the what was the state? What's the state of this order? When was this order first placed? So you need the state view in order to make a decision whether to allow them to cancel the order, because you need that date when the order was placed and see, well, it's beyond 30 days, can't cancel the order. So right, so uh, state views and are very important, but they're just derived from the events, which are your source of truth.
Got it. I
Mhm.
just had a quick question. Maybe we can keep going through this topic. One question I had was like there is there is this upcoming phenomenon. We've all heard about Internet of Things, smart home, smart devices for a long time now, and there is a new phenomenon of like decentralized physical infrastructure networks. They're calling it DeepIn. We made a video about it, and
Yes, you did. I saw that.
in Zadwell, and like the question I have is like the reason that even we made the video was so fascinating because like today, uh, the, let's say you have a smart home or you're using like different appliances and things like that, and there's no control of like who sees the data and who you're sharing the data with. And how you can control, right? I mean, maybe you want your city to see your data, but maybe not the entire country, for example, right? I
Uh-huh.
mean, are you able to? So you are able to basically fine grain access control from a data point of view, how much of data you're allowing to be shared and who can see it and for how long, right? So all of that can be fine grain control from a data point of view. So
Mhm.
I just had a quick question. I was just overlapping as we are going through state views and events. And let's say we are going through a ledger and we have a bank and different transactions are happening. We're going to a grocery, we're going to a Home Depot, different transactions are happening. And are we able to also fine grain restrict in terms of like who can see and what and whatnot? I mean,
Well, yeah,
just
you would have state use. This is just separate from security, but you can certainly apply different security rules for different state views, right? So,
right.
so who can see certain state views and who cannot, right?
Okay.
Um, yeah, and who can perform certain actions, certain commands, what they call them. So it's there's commands and there's events, right? The events. So what happens is somebody issues a command,
Right.
and then there's a business domain class that gets engaged to see, well, can the customer do this operation? Am I going to allow them to do this command? Yep, their balance is good. They don't owe us any money. Oh, do you want to cancel? Oh, yeah, sure. It's been less than a month. They can cancel. We're gonna let them. So your domain class determines that, and then what does it do? It creates an event called order canceled event and puts that in your event store, I call it. So,
Got it.
or people call it event log, but it's more than a log because
Got it.
it's an event store. What occurred? Yeah, so you can certainly put security. Actually, our library leaves security out because you can implement it in various ways using all sorts of security techniques. But it's kind of outside of our scope. That's another big ball of wax. But what we
Got it.
wanted to do is give uh, the bare bones minimum. Uh, if you look at our library, by the way, is called VESA. I know there's already VESA out there. It's for video. It's an architectural group, I believe, association for video stuff.
Right.
But
Right.
VESA, from a software development, we've coined is short for vertical event sourcing architecture. That's what it is. And what it
Got it.
is it combines microservice architecture, domain-driven design, um, command query responsibility segregation, vertical slice architecture, and event sourcing. And the library we created. So you might ask, okay, if this is the way to go, like event sourcing plus all those other patterns, how come how come we haven't developed things that way? Well, the answer is partly that event sourcing is relatively new, just like it's even newer than domain-driven design and CQRS, right? But also because it's difficult. It's challenging if you don't know what you're doing. So what we tried to do with we published our library here and we gave a sample eShop application using the VESA library. What we've done is we've tried to remove all that complexity from the application developer so that they can focus just on writing application code, business logic, and leave all the plumbing complexities of event sourcing and vertical site architecture and all of those things to the library. And in fact, we also have built an AI code generator that that can use that generates application code that calls VESA,
Like a
that calls
co-pilot.
much better than Copilot. Like if you read articles about real life people's experience with Copilot, it's good for kind of rudimentary tasks, but for enterprise code. So you see, our approach with VESA is two pronged. We let the AI LLM generate the domain uh, commands, events, those sorts of things, because and the attributes.
Right.
So like the example in the articles that we have, uh, you can actually Google. It's also in the medium.com
The
somewhere
part
there.
two.
No, it's there's a link to, if you go all the way down in each article, there should be a link to an AI code generator. There's a series of articles. Is there? Can you go further? Yeah, there should be one on.
Oh yeah.
Yes,
Yeah, right here. Yeah.
AI code generator. So we talked about uh, a hybrid approach where you use artificial intelligence to generate the domain application events, commands, stuff like that, and then you use a human being's component library. So for the plumbing services, so and to generate the UI, the application code based on those JSON. So if you go down, scroll down there a little bit, VJ. Yeah, a little bit. So it gener so the example here was a use case, a doctor's appointment. So if you go down, so we just type doctor's appointment, and it, you see here the command scenarios, schedule an appointment, and it says uh, command data. It says patient. You can't see it there, but if you scroll to the right, you see patient ID, patient, that sort of thing. Like schedule an appointment, you have an appointment date. You have to go down to the bottom and scroll to the right. Yeah, there, yeah. You'll see attributes like appointment ID, patient name, blah blah blah. These were generated by the LLM, right? So we
Does that require like a Chat GPT subscription or like a Gemini?
ChatGPT or whatever data engine you require, because it's configurable. You can say which engine. You just have to give your key, your key that allows you to make the call, right? That
Got it.
you've
And
gotten
this can
from.
be done from Visual Studio.
Yes, yes.
Okay, got it.
So here you this is what we need the AI engine for. Once we get, so this is for commands, CQRS. All the commands are on top. The query scenarios are on the bottom. You see the get appointment, get doctor appointment, so forth, right? So you need the AI engine to generate your application logic in form of a JSON. Once I get this, our code generator takes this information and generates the application code that calls VESA. We found it to be more accurate than at one point we used the AI engine to also generate the application code. But at this point in time, with ChatGPT 4.x, it's still not as good as a human beings reading this JSON and generating the application code. And the application code we generate, if you scroll up, actually scroll up a bit, so way up, so way up, yeah, those things in black, DJ.
Those things in black.
Yeah,
Okay, got it.
it generates all these files for you, all of these files, and it generates the projects. It does the CQRS separation. It does the vertical slicing. It does the domains for you, domain logic. It generates the domain class, the command, the query. the handlers, and then it makes the calls to VESA, to the component library. Yeah, and it does the configuration, startup configurations. You can see on the left there, that's the event. Appointment, the event handler, appointment schedule handler, schedule appointment command, domain handler. It generates all this code for you. I mean, you could code this by hand, right? But we also have this code generator that really is
So,
it's a
so for people using the library, so they will have to use the code generator to generate these classes for every
only
domain.
if they want
Uh,
to. It's a You know how Visual Studio has the scaffolding
Scaffolding, yeah,
tool,
yeah, yeah,
and
yeah.
it's almost nothing, right? It's so bare bones, like compared to
Got it.
this. Compared to this, the code that
And it would be basically generating in the format of vertical sliced
yes,
CQRS approach.
yes,
All right.
and
Okay.
event sourcing, and event sourcing.
And event
So
sourcing. Okay.
the
Got it.
complexity of event sourcing is taken away from the application developer, and it's put into the library. You don't have to worry about the event sourcing part of it. So
And
um,
question here, Spider. I mean, like from a let's say a new developer comes in and starts using this library. I mean, and because AI is AI and it doesn't understand the business domain, right? I mean,
well, no,
uh,
actually, it does. We
it
we
does.
we use AI to generate the business domain logic. Like you
Got it.
see, the word schedule appointment and reschedule and cancel appointment. I didn't come up with those terms. I just put doctor's appointment
Got
and
it.
I said, ChatGPT, can you please give me all the use cases for a doctor's appointment application? And it
Got it.
created those events for me. I didn't do them.
Perfect. Okay.
Once we get
Perfect.
that JSON with all the business context inside that JSON,
Got it.
then we generate the application code from it.
Got it. Got it. So all you need to know is the name of the domain, name of the business domain. That's it. And then from
Well,
there,
that
it's able to.
JSON file, scroll down again there, VJ. That JSON file that you saw,
Not this one, the other one, right?
yeah,
Yeah,
yeah.
this one. I'll unzoom a little bit. Yeah.
But
Okay.
actually, you can see, yeah, you see there. Here are this is what I really need the AI for,
Yeah.
to generate the business terms. What are the business processes? Scheduling an appointment, rescheduling an appointment, canceling an appointment. Oh, what are the
Right.
names of the events that would be generated from it? What are
Right.
what are the attributes? What are the properties of the command? What are the properties of the events? So the AI does this for me, and after that, I can take over and generate the application code as well, calling the VESA component library, right?
Got it.
So it's a tremendous tool, scaffolding tool. Like
Got it.
this is no ordinary scaffolding tool.
Yeah. Yeah.
This really like accelerates your startup process, right?
Yeah.
Uh,
Yeah.
I have a specific article on the vessel. If you Google uh, medium.com, the VESA uh, component library, uh, I
Is
believe
it in your same
it's in the
medium?
same series. You'll see it as well there.
This one?
Yeah, it's probably actually go to that one, and you'll find it. It's the same one, but there'll be a in the very bottom. There should be like because we published the VESA source code. Um, Go at the very bottom that will list other articles. Oh yeah, this is it. This article here talks about the VESA component library on a very high level. Uh, the kind of code it generates: query handlers, command handlers, workers. These workers uh, update state views, for example. Depending if an event occurred, you have to update a bunch of state views that are interested in that uh, in particular event, so
Right.
that you're going to have multiple current states. Each current state is germane, is tailored for one particular state view, right?
Right.
So, for example, what is a state view? You can have an order state view. You have a customer orders, like from perspective, a customer order state view, or you can have a daily orders state view,
Right.
or cancel order state view. So all sorts of uh, views of the state of the system, you would generate that for from the events that were saved. Your source of truth are always the events, and you can always recreate your state view from the beginning of time. Now you might say, "Well, Spider, it's not going to be take too long a time to generate the events from the beginning of time from 10 years ago." So there is event sourcing as a way of mitigating against any performance hits. And what you do is you can save what they call snapshots, right? So Greg Young calls snapshots. So you can save, let's say, a snapshot from up to last year. And in fact, you have that in your bank, right? Like if you want to look at your bank transactions, you can go, let's say, up to the last year, right?
Yeah.
But if you want to go more than that, you're gonna have to like pay them more money to go to get it from the archives, right?
Yeah.
Right. So otherwise, there's a hit if you want to go past a certain time period. So
Or
and
walk to
that
the branch, do it manually. Yeah, whatever. Yeah, we
yeah,
have options.
but I mean that's up to the business what they
Yeah, yeah, yeah.
decide. Uh, where to start building. Maybe they're interested in the last 5 years. So okay,
Yeah.
so the first 25 years of this company, we're gonna say take a snapshot of it at that time, and in the last 5 years,
Yeah.
we can build views from the last 5 years. So if you ask your company, what was the state of our company
Yeah.
on July 14th, 2021?
Yeah.
It's trivial to do in event sourcing. But
Yeah.
you try to do that on a current state system. You
Yeah.
can't do it. You can't do it.
Let me be let me bring a different context to this conversation. I mean, we just spoke about monolith, right?
Yeah.
And like how we have challenges in terms of like getting shit done from a business administration governance point of view and from a managerial point of view. It's that's not their priority. We get it. We understand it. And from a technical background, I'm super excited to use something like this, like the VESA, the vertical event sourcing library. That will be hugely, tremendously helpful for developers writing the code, and it's going to be the way you structure code, maintain it, it's going to be very useful, right? And what is the business motivation from a managerial point of view? And if someone is hearing this conversation, like what would be their motivation to go in this direction? Of course, the developers have always, at least as far as I know, they try and push things that are technically really like the optimized way of doing it, more
Right.
efficient, things like that. But end of the day, when it comes to getting shit done, sometimes you know what I'm talking about. It doesn't go through the check mark. So, what is the business motivation for them to adopt something like this?
Well, we have lots of business intelligence platforms that help. They're tools to help business make decisions, right? Basically, they're going to track trends and so forth that may not be discernible by a human being, but a machine can. Uh, it's even easier to do all of those things, and maybe even you don't even need some of them because the event sourcing is naturally conducive to uh, making queries about the system because it tracks all the events. So
Right,
you can create any state view that you want, that you're interested in, and subscribe to various events that affect that state view. Because it may not be all the events. Some events you may not be interested in.
right,
Like if you're in the shipping department, you don't care if someone paid their bill or not. You're
yeah,
not interested in that. You're just interested whether we delivered it on time, right?
correct,
So you're not interested in the event. Customer paid the bill. Don't care.
yeah,
So your state views are not, yeah. So event sourcing, I would say, makes business intelligence even um, easier and more. Uh, there's
like from a reporting point of view, from a
Yeah,
dashboarding point of view,
yeah,
like a right is that what you're referring to?
exactly.
Of
And there are actually other tools like I mean Databricks, which Microsoft has a version of.
course, yeah,
All it cares about is we're gonna have an article about that in coming up,
yeah,
where a bunch of events It just takes a bunch of events, and
Right.
it can generate all sorts of intelligence based on those events. But it's so much more difficult to do that if all you have is current state and an audit trail, because we've
Got
already
it.
talked about it. You lose
Got it.
business context,
Got it. Got it.
right?
So
You
what
lose
what
business context. So
so yeah, no, 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 that's
and
beautiful
and
actually,
then, and
because
then
from a decision making point of
yeah,
view, all the decision makers in the business, basically they want the more information they have at their disposal, the better decisions they'll be able to make,
yeah,
right? So and to get to those better decision points, libraries like this is going to enable that. It's going to be
right.
enabler for better decision making, right?
And from a security standpoint too, like if someone wants to know, okay, hey, this data changed.
Right.
Who did it? Okay, you can go to an audit trail. You can find out who
Right.
did it,
Right.
but you don't know why they did it. What were they doing
Yeah.
that made that change? What business process did they invoke
Right.
that made that data change? You don't get that.
Yeah.
So that's why by having the event itself stored, you know exactly why, what happened, what was the business process executed, right?
Right.
So that ended up giving this current state, which you're going
Right.
to derive, by the way.
Got it.
Uh,
No, no, makes perfect sense. Yeah, sure thing. Yeah. So I had that question. So sorry for interrupting. So what was that? Was there another article we were going to go through on vertical slice or?
well, that article on the code generator explains like how if you had this at the disposal, we haven't decided where we're going to publish the code generator as yet. The
Right.
VESA library is free. It's open to anybody. You're free to modify it as you wish. Use it for your. You just can't package it in another library and say, "Oh, this is my library," right? But you can definitely use it in your business and change it any way you want. Modify it. Go ahead. Uh, just like I say, you can't say, "Oh, this is my library," uh, and don't go and
Got it.
sell this as a competitive product, right?
Of
Yeah.
course. Are there any commercial restrictions for anyone willing to use it?
Yeah, just that. I've just said it here. You're licensed to use and modify it as needed for your application.
Got
You're
it.
not free to package it as part of any other library and say,
Got
"Oh,
it.
this is my library," right? You just
Perfect.
or cosmetically change it or use AI to slightly change it, yeah, and
I
then say
know.
it's, "Oh, this is mine." No, so we really
Yeah.
are just giving this to the world. I honestly think there isn't a simpler event sourcing library out there. You cannot get simpler than what we've done, and it's totally configurable.
Yeah.
Uh, and not only that, VJ, we're going to give you a bonus. You can switch from file system to SQL Server to Cosmos to blob storage by one simple entry in your app settings. One
Wow.
simple entry can
Wow.
change from one platform for your event store
Yeah.
or for your state views, either one. Your state
I,
views or your event store, you can
I saw
change
that
the platform.
configuration somewhere. I'm just trying to get to it.
Yeah,
It
yeah.
was in the article, isn't it? Uh,
I'm not sure if it is in the article, but it's
I saw the config somewhere. I hear, I know exactly what you're talking about.
yeah. So
Uh,
so so from a standpoint of a developer, you can even write to a text file your events and your
yeah,
state views,
right,
and you can go into a folder and look at it, right? And then you can change your configuration and you can write it to a SQL table, or you can write it to a Cosmos container, or you can write it to blob storage with just one entry change. So I mean, eventually we're gonna have Oracle as well for an Oracle event store and an Oracle state view store.
right,
That's coming. Um, but but the idea is the source code is actually there. If you want to write one for Oracle, you can do it. If you can't wait for us to do it for you. So yeah, that's the added bonus. You can switch from one storage platform to another for both the events
right.
and the state views by just configuration.
Is there any when people are switching data stores between Cosmos DB or SQL or Oracle or files? Is there any help that they can get from AI to generate skeleton structures of the data store at all?
Well, the structure is pretty much that's not the problem. The problem is in
That's
the
not
code that writes it. So we've never tried it, to be honest.
no. Would the structure be all auto generated by when we actually
Well,
run the code?
in an object database, the structure is defined. It's the structure of the entity itself.
Got it.
Right?
Okay.
In a relational database like Oracle, I think the tables, we've also defined the tables uh, to match. We've defined the tables and the events. It's all predefined what the tables are going to be. Uh,
Got it.
but the entity names would change from one business case to another. Yeah.
Got it. Got it. No,
So
that's
there's a lot in these articles. We published a whole whack of them. There are more coming.
I'll pin the link. Yeah.
Yeah, I'm actually a bit behind in my follow-up article to the AI when we introduced VESA.
Right.
So there's an article that will talk about the use case, the eShop container sample application using VESA. The first article we wrote on the AI code generator was on a very high level, what kind of code it generates.
Right.
But in the next article coming, I believe this week, we'll be talking about the eShop application as a sample app that uses VESA.
Right.
But I mean that's published in GitHub. You can look yourself. But I will go through the code in this article, the forthcoming article.
Oh no, that's amazing. No, Spider, thank you. I think that's beautiful that we could go through this. Is there any other thing that you'd like to add on the event sourcing topic at all?
Yeah, I would say this, like um, after tasting event sourcing, I made a pact to myself that for any greenfield application, I'll never write it any other way. I think once you see it, it just makes sense.
Yeah.
The problem is how to mitigate the complexities behind events, and because as you write an event,
Right.
there stuff has to happen. Like you may generate what I call you might propagate other events that are related to that event, and then you have to update state views as well that are interested in that event. There's some
Right.
complexity there, but
Right.
so that I think is a barrier for a lot of people. That's too much uh, complexity for them, and that's why we created VESA.
Yeah.
We created VESA to take that complexity away from the application developer so they
Yeah.
can focus on business logic and yet use event sourcing, vertical slice architecture, domain-driven design, all of these application patterns, best practice. You can do it,
Yeah.
and you don't have to worry about the complexity of implementing it. You can
Got it.
just worry about your business logic. That's
And
that's what I would say is the main driver for this. And then if you have our AI code generator,
of course,
it's even a step
even
beyond
better.
that.
Even
Even
better.
better. Yeah,
Couldn't be better.
yeah,
And this is for anyone using it. It's not a. It's more of a like eh, the moment you hit the API, everything that's happened within the business domain.
yeah.
That's where this library
Right.
comes into the picture.
It's not a front end kind of thing. Yeah,
It's an API backend.
yeah,
It's a business layer
yeah,
library
yeah.
that sits between the front end and the database. It's in between where all the
Yes,
important decisions for the
right.
product are being made. So that's where
Yes,
this comes into picture. So right.
yes.
Okay.
But the thing is with the way event sourcing is, it really is a tool to and domain driven design. It's really a way um, of splitting your enterprise in a way that makes sense, in the way that they can work independently from each
Right.
other, but
Right.
harmoniously as well.
Right.
Uh, and you're not constricted where if one system is down,
Right.
then everybody's down.
Yeah.
You have And I know when I worked for a transportation company, the first day I started, my manager said, I wish we could have it so that if one of our systems is down, that it doesn't bring the whole damn system down.
Right.
And
Yeah.
that's we achieved it.
One point of failure. Yeah.
Yeah. Like all your microservices should still function okay, even if one of them, all the other ones, even if one of them goes down. Why?
Right.
Because all your data that you need to perform your business is
Yeah.
right in your domain. You don't
Yeah.
have to go to some other domain to get it.
Yeah.
So that's how you can achieve that kind of autonomy with domain-driven design. Yeah.
It's so funny because like how many times have we seen like system under maintenance and the entire website is shut down,
There you
right?
go. There you go.
It's like very often, right? I mean, how even like it's like very recently also. I mean, like so I think that it is
And
time to like probably a sub feature of a feature doesn't work. It's fine, but like you cannot shut down the entire system, entire website
I
for
think, Vijay, you brought up a very interesting point which you didn't cover. The testing and deployment. Okay. If obviously from a testing standpoint, if you've got a monolith, okay, if you touch one thing,
right.
you got to test the entire monolith, right?
Yeah,
And in fact, I can't tell.
and rebuild all of it. Like
Yeah, no, but I can tell you right now, I'm working for, I shall not name the institution, but they're spending, they have 300 resources
right.
allocated just for testing because they have a monolith. Now they're trying to break away from monolith. They brought me in
When
to
you say
help break it
resources,
up.
300 people working on testing, software testing
Just
alone.
testing for every release.
Wow.
Wow, right. Yeah,
Wow.
wow. Every release. And they can't release in an agile fashion. It has to be, if you want to release something uh, in 6 months, you got to finish it by today.
Yeah.
And then in 6 months, it's going to get released. Because why? They're going to
Right.
unleash those 300 testers in the
Yeah.
next 6 months to test the entire application, monolith
Oh wow.
application.
You
Yes.
know what? You know what? Let me add cherry. I don't know. I'm at least I'll try to. But this is what I like. I was trying to connect. Azure. Sorry, not Azure. Agile.
Yeah.
Scrum.
Yeah.
And we do user stories all the time.
Yeah.
And basically, when we do this, we'll be able to map it at the level of user story to a method. Right?
Yeah.
It can go that deep. Right?
Yes. Yes.
Basically, there is just one person assigned to a user story, and then he's working on a one or two methods, and he can actually complete it,
Yeah.
right? Here
Yeah.
are 5 user stories I completed, and without having any dependence on other user stories,
Right.
right? Because most of the time, oh no, the developer A is probably dependent on like developer C, like right, and you get it.
Yeah.
There's a lot of like interdependence between the teams,
Yeah.
and so it makes it completely independent, and you can just finish your user story and then call it a day.
So, from a development perspective, from a testing perspective, and
Right,
from a deployment perspective,
right,
why? So that's why they can't release because they have to release the whole monolith every time.
yeah,
Imagine if you have broken up your application into
yeah,
various domains where each one is independent. You
yeah.
can release just that domain, right?
Yeah.
Just that domain.
Talk to me in the language of readily shippable product or MVPs or things like that. When you say that we'll be able to release a percentage of a product, like right?
Yeah, I mean, first of all, even from a domain standpoint, that's already a big win. If all
Right,
you have to do is just release for your domain, but
right,
you can break it down even further. In vertical slice architecture, the way we've done it in VESA, it all goes into one assembly. The each vertical slice goes into all the vertical slices go into one assembly.
right.
Um, but in fact, there's nothing stopping you from putting one assembly for the vertical slice. That's an extreme. But
Yeah,
in that case, your Unity deployment is by feature, by one particular vertical slice. You could even deploy by vertical slice at its most extreme. I know my partner Timur uh, in our organization IO Cloud Systems that's behind VESA. He's very much into wanting to deploy by to have a separate assembly per
by
vertical
slice,
slice.
by the slice.
By slice. You could say, wow, wow, that's going to be so super many slices, right? How do
Too
I
many
manage it?
files. That's it. That's what it's going
Yeah,
to be.
but the thing is, you see, they said that too about databases, right? What you're going to get a DBA going complaining about, oh, why would I want a database per domain
Yeah.
and multiply my headache multiple
Yeah.
times? Okay,
Yeah.
that and it's true. If we didn't have tools like Terraform,
Yeah.
right? Uh, Terraform and what's Microsoft's tool? Terraform is I like it better than Microsoft's tool. I forget the name right now.
Like the DevOps.
Yeah, the
Like
DevOps tools.
uh,
DevOps tools are so much more advanced right now because you're coding the infrastructure. You're not
correct.
clicking a UI by hand, right? You can
Right.
code the infrastructure. You know, the tools, Terraform, you no longer are a slave to, oh, I have too many databases. That's just that's just your excuse for not using more modern deployment tools, DevOps
Yeah.
tools, right? If
Yeah.
you use Terraform, this should not be an issue,
Yeah.
right?
IAC. IAC. Yeah. That's what I was looking for. Infrastructure as a code.
As code, exactly. Like
Yeah.
you don't need to be a slave now to say, no, 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 that's too much work. I have to click so many. No, you write code to manage your multiple databases, your database per domain. It
Right.
shouldn't not be. That is not an issue. And so I'm going to say as well, if you extend that to having so many files per vertical slice,
Yeah.
that's no longer. You can release by vertical slice. It's awesome, man.
Yeah.
Um,
No,
right?
that'll be amazing. I mean, like say even if like one class is broken down into let's say 20 features,
Yeah,
and let's say each, I mean, let's get super crazy and say let's each feature is a class by itself, a slice, sorry, not a class, a
yeah.
slice by itself. And if you were to compile it, I mean, this is like, can we go crazy and have like 20 different like DLLs or like 20 different files for each
Absolutely.
slice?
You can have a million. I mean, it's up to you. It's up to your imagination and how you
So
want to deploy, right?
it's going to be we could probably at namespace level we're going to
Yeah,
distribute
yeah, exactly.
at the slice level. So each
Yeah,
slice a file, 20 features, 20 files can be done.
sure. Why not? Why not?
Amazing. That's beautiful, man.
Why not? That's
Yeah,
my buddy, my partner teamwork. He was the
yeah,
one who said, Spider, I think we should really divide these even further, right? Don't have one
yeah.
DLL for all the vertical slices. Have one DLL per vertical slice. I said, damn, that's good. But I mean, for the
Brilliant.
purposes of our exercise, but there's nothing stopping other people from doing that.
Yeah,
That's why I love it, vertical size architecture, because your code, your infrastructure worries about, oh, it's going to save it to this particular table or Cosmos container.
right,
That's the job of the backends, the infrastructure stuff, right?
right.
But uh, from a domain standpoint and interface standpoint, yeah, have one assembly per feature
Got it.
per
Got it.
vertical slice. It's
And
awesome.
and people who are really curious about, passionate about like the code and how it is structured, is there any early flavors of that we can give them? Should we quickly peek into the GitHub, the
Yeah,
repository that
go
you guys
go
have?
go into the GitHub.
Yeah, yeah.
Take a look at
Let me do that. I'm gonna share the real quick. Oh, guys, you've been talking for a long time. What are you talking? What are you guys talking about
yeah.
actually? Right. So let's. Should I go into Visa?
Well, no, yeah, go into eShop to show how it's used, right? Click that.
Yeah.
Click into ordering. So we try to mimic eShop containers as well, right?
Yeah.
So I click into inquiry is the Q in CQRS. It's the read operations, and
Right.
management is the write operate. The C in CQRS, the command part. So it starts out with management, because what happens is you have an API. So you see the API there. That's where you get so this API can be right now it's an HTTP request, but it could be an event that's pulled from a service bus. It could be a Azure function that
Right.
triggers the API. We just wrote a straightforward HTTP uh, API, but it could, like I say, be a Azure
Yeah.
function.
Gets and writes and everything. Yeah.
No, the API is just a trigger. How does the service get triggered, right?
Right. Of course.
So that's just, and right now that's just an HTTP API. Like I say, you can have Azure Function API, you can have a Service Bus API, right? So that's how the thing is invoked. And
Got it.
and the application layer is where if you open the application layer, and there's very minimal code in the API, right? A lot of it is um, yeah,
Abstracted.
yeah. The now if you open
E-shop, this example is basically an e-commerce
yeah,
uh,
yeah.
example. Okay.
And actually this application layer is make believe. This interfaces are just make believe, and I
Yeah.
wouldn't. They're actually I would de-emphasize this application layer because this is specific to uh, an eShop application. So I would de-emphasize this and open events. Sorry, service
Close it.
services.
1 second. Let me go into. So it's still
So management, ordering
uh,
management.
ordering management application, right?
No,
Okay.
no, not application. Sorry, close that because that one is all make believe. Open to service. Yes. So
Place
here you
order.
can see this is the vertical slice. Place order command, place order domain. So that place order domain. So this command has all the aspects. Like if you make a request, you're gonna have to give some items,
Yeah.
uh, right, and payment and all of that. The domain is the business logic and all. So it's gonna do some domain validation, and then if it passes all the validation and it's okay for you to actually place the order, it would create an event called order placed event. There in line 60 creates an order event, and then it says events.add, and the handler, if you open the place order handler, so this guy only it inherits from command handler with the generics there. So you don't see hardly any code here. Why? Because all the work is done. If you go in, you see line 28, it says handle async because the
Yeah.
base class command handler in the VESA library handles the storage of the events for you.
Right.
So you're just doing some validation, business validation in lines 20 to 26. And then the actual base class in the VESA library for command handler, it does all the work for you. So if you want to see that code, you have to open VESA, and VESA
Uh,
right
yeah. That's a core. That's a core library, right?
yeah. So right now we've just made it very very simple into 7 projects.
Can you take
Um,
us to this one?
yeah, so open core, and I deliberately put the abstractions and the concrete class in one just for so we can have limit the number of assemblies, but there is a version of this that's all split up. So go into the not abstractions, but into the infrastructure within core. Yeah. And open command handler. Yeah, open that. And you can see this and look at the handle async method. So there's 2 versions, one that requires a state view. Like if you're placing an order, you probably don't need to know anything about it's like a new operation, right?
Yeah.
When you're doing canceling an order, you need it's kind of update. Like you need to know to get a current state in order to know, okay, can this order be canceled? Because I need to know when the order was placed
Yeah.
to apply my business rule. So you can see in the second command handler has a second generic parameter, T state view, right? Because it needs to know the state view in order to perform the handle async.
All generics.
Yeah, all generic. So the code here in line 68 will retrieve and hydrate the state view for you. Uh, so it's available to you to make a decision in the descendant class whether to uh, in that process async in the descendant class it can decide because the state view will be available to the descendant class and it can make a decision based on that state view whether to go ahead and generate an event, create an event for storage, right? But the
Yeah.
simpler version, the simpler version of the command handler is the one that in the IC command handler with just the command, it doesn't require state view in the generics in line 6. There's no state view
Yeah.
there. So the handle async here in line 27, it just calls the domain method to say process. It doesn't need a state retrieve a state view, it just goes process. And
Yeah.
then the next line, it uses in line 28, it uses the event store that's injected to this handler to add the event to the event store. And that's it. So that logic doesn't have to if you go back now to the place order command handler, this logic you won't need to do because it's in the base class, right? Your place
And
order,
and connecting to the message hubs and how you do it async, uh, all of that can be configured, I assume, right?
yes, yes. I mean, you need to write an event handler that says, I want this event published. Because
Yeah.
certain events might be only internal to your domain,
Yeah.
but certain ones you might want published to an external event hub, a message hub. So that's you have to write an event handler for, but there are I have a built-in one called publication event handler, which will which you if you inherit from it will do the work for you. You just configure the message hub that it's going to publish to, right?
I
Uh,
mean, like, quick question. I mean, like, I mean, this is nothing to do with the library, but actually, just trying to throw this question to you in terms of like, we have always seen this cross origin problem between when we are dealing with multiple domains, as when it's especially going from a front end user
yeah,
interface to an
yeah,
API. We have always seen that problem. Um, but now we are living in a world of like everything is in the cloud and people are using multiple clouds actually. So maybe some of our source code could be deployed to Azure and something to be GCP or something in AWS. Let's say we are publishing a command and maybe Amazon switched out how they process orders. They shut down one vendor and they're going with a different vendor, for
right,
instance, right? So when we are transitioning to a different vendor, let's say they're not using Azure, they're probably using AWS, for instance. So
yeah.
is there a way to leverage some part of this library when it is like actually cross domain and cross cloud
Yeah,
uh,
so to be
as well?
honest, we didn't put anything for cross origin configuration.
Right, right,
Um,
right.
but that's a good suggestion. We'll have to put that in the library, but we haven't done that as yet. Like
Yeah.
if you needed to do it, you have to do it by hand right now.
Right. No,
For,
no, no,
for
no.
cross origin.
Cross origin. Yeah, yeah. That is a reference. Again, when we're working with, of course, multiple cloud providers,
Yeah,
is there something that we can leverage that we already have? If you're able to, basically, someone has to publish it and someone has to subscribe to it. Correct.
right, right.
And if you have the VESA library from a subscriber point of view, we can publish it from here, and they can receive the event that is published.
Yeah,
It can still look seamless.
yeah,
Doesn't
yeah.
matter what the cloud provider is. Correct.
Yeah, yeah, that's right. Like for example, we had this experience actually, VJ, in our last work together, where we were receiving events from Kafka,
Mhm.
the Kafka streaming platform,
Right. Right.
uh, and I believe it was an AWS infrastructure,
Right.
and it we were receiving it and listening to it from Azure,
Got it.
from our services in Azure. So
Got it.
certainly there, yeah. So basically you're getting the URL to listen to
Yeah.
the yeah
On a port or yeah.
on a
Got
port.
it.
Yeah, yeah, that's it exactly. These can be configured, so
Got it.
for sure.
Got it. Perfect.
Um, yeah, so I mean, you can look at the code. You can read the article on this on how to. But it's like I say, it's really dead simple. And if you use our AI code generator, it's even simpler. It's even simpler because your scaffolding is built for you,
Yeah.
and it's a hell of a scaffolding too.
Got it.
Um, um, yeah. So
This is good. This is
it
good. Super good.
it really removes the chores of storing events
Right.
and generating state views away from you if you use our AI generator because it creates some what it feels it knows about your business.
Right.
What typical state views are you interested in? And in fact, Databricks does that. Like Databricks is a very expensive tool. Microsoft,
I've
I think,
used it. Yeah. Yeah.
has a version of it, but it uses AI too to anticipate, to generate some of these views that it thinks you're going to be interested in, based on the events that you publish. Yeah,
Right.
and so, but if you can't afford Databricks, you can write your own.
Yeah, it's a little expensive, no doubt.
Yeah, yeah, yeah. Um,
uh,
but this is a way for your developers to create their own state views, um, and generate them based on the events. Because remember, as long as you have your events, you can do anything. That's
right,
your source of truth.
right. Now, this is terrific, man. So as we come near to the closing, yeah, before we get into the keyboard or music, I just have a few one or two questions. So what do you think is it's a more of an open-ended question. So how do you see the future of tech, and how do you see the future of AI? I mean, I often say that technology adoption, especially in these days in 2024, is no more a choice. It's more of a necessity. We put that everywhere. Because I so believe it, because I don't think it is a choice anymore. You got to adopt it. We have seen
Yeah,
stories over and over again with Blockbuster not adopting at the right time, losing it to Netflix, and so is with the taxi unions, with Uber, and with over and over again, right? I mean, when businesses make a choice that's much delayed, they end up losing the business itself, right?
right.
So I'm definitely I'm looking at the future is very inspiring. It's very promising. I'm hopeful about the future, but like how is what is your thoughts on future of tech as a whole?
So that's an interesting question because, the VESA library was written by a human being, but in fact, my partner wants, to train, an LLM, a local one, uh, to do what VESA does, or at least, to do the code generation part that currently we have a human being generate, uh, the application code based on that JSON that you saw.
Right,
Um, it reads that JSON and uses, templates, predefined templates, and reads that JSON and parses it to generate the application code that calls VESA. My partner wants to have that part of it, which wasn't very accurate currently with the LLM with ChatGPT 4,
right,
that it wasn't as accurate as, our templating, the code it generates. That will definitely change in short order. So we're working on training an LLM to generate the code. But as far as the future, so I would say this, that what you want to do is get away from writing, repetitive plumbing code, um, and at the same time, uh, employ these best practices architectures, uh, and certainly event sourcing, domain-driven design, CQRS. You want to get away from the monolith. Um, and the problem is that people wrote this monolith 30 years ago or
yeah,
more,
yeah,
and it's very difficult for them to break away
yeah,
from it because the cost is exorbitant. Huh?
right,
So, so our organization can show you how to do that, but essentially you're going to try to take a small domain that you can break off the monolith, and turn off that feature off the monolith to go to your little, um, properly designed, architected, event sourced work, and then it can go back into your monolith, and you could keep doing this indefinitely until the monolith dies, right?
right, right.
Strangulation, right? Yeah.
Now
So,
that's
yeah,
perfect.
yeah, but, is it true that AI will eventually, replace the programmer? I think the type of programming work will change. Programmers will still exist, but they'll be either teaching the AI to do certain things, and so the work might shift from writing, routine plumbing stuff,
Right,
to more to other concerns.
Like more of like it enhances the productivity, and it's more than a productivity enabler. Uh,
Yeah,
right? I mean, they can
yeah,
focus on the business context and business domain, and then let's
yeah.
just focus on the business domain, and then keep churning out code, I guess.
Well, no, but I mean, in terms of even just technology as well, the role of coding might be other than business, yeah, is
Right, right,
to write code that trains the AI to write
right.
code. Like
Yeah, no, no,
yeah,
that,
you're
that's
training the AI to write code, right? So instead of
right,
writing the code yourself,
right.
it's like it's the same idea. You write infrastructure as code. What are you doing now? You're not doing things manually anymore. You're writing
Yeah,
code to train the infrastructure to do
yeah,
certain things. So I think the AI, the developers in the future
yeah,
will have much more um, interaction with the
yeah.
LLMs themselves than they do today. I
Right,
mean, we have data scientists that are doing a lot of this work, and I'm not sure it's trickled down to the masses in terms of your average developer. I don't think we're there yet, but
right.
I believe that uh, the shift will happen where your most of your work is coding the AI engine, telling
Yeah,
it to do what to do and stuff like that, and
yeah,
how to do it rather than doing it yourself,
yeah.
right?
No,
So,
no,
so, it, so
I see that
yeah,
with Lambda functions and in AWS and Azure functions. You're just focusing on your module, your feature. Just focus on that, and then when it coming to an enterprise grade deployment, enterprise class application, you can just focus on your domain and your feature that you're developing, and then just own it and then deliver it. That's as simple as that. So
well,
uh,
even so
the
far as to
distraction is less. So,
yeah, but even so far as to train your AI machine to be better
oh
in
yeah,
generating domain information, domain
right,
logic, like
right, right, right.
so, the
AI doesn't know
focus.
today how to do a vertical sliced, how to generate a vertically sliced code. It doesn't
Yeah,
know it today.
well, we're working on that.
Yeah, yeah, and
We're
it's
working on that.
understood. And then people when they start using your LLM, I mean, based off the AI responses based off your
Yeah.
LLM, then they're going to get vertical slice based approaches. And
Well,
yeah, yeah,
so what we offer in VESA is sort of like a stepping stone to that. Like use the AI library to generate the domain commands, events, handlers,
right,
uh, and then use our code generator or to generate application code that calls VESA. Uh, it's kind of like a baby step towards the full shebang where your your artificial intelligence will do everything
right,
for you, but you still have to code that. You have to code it to make it to do it for you, right? You
got
have
it.
to give it instructions on how to do that, and we are working on that.
Yeah, no, no, that's perfect.
But we have in the interim, we have a solution for you right now. You can do it right now. You
Right,
can use AI and to help you, and you can use our component library to do all the grunt work for you.
got it, got it.
And just imagine this from a testing perspective, VJ. We talked about it a little bit, but not just from a DDD standpoint, but when you have
Yeah,
a component library that's fully tested
right,
and you have very few lines of application code, that
right.
means your unit tests drastically drop too, right?
Got it, got it. So that's fantastic, Spider. Thanks for getting allowing us to get into that world and knowing you a little bit more and going through the vertical slice architecture and event sourcing library. It's amazing. If people have to reach out to you, what's the best way they can find you?
We're there's a you can email us at iocloudsystems@gmail.com, iocloudsystems@gmail.com.
I will put that in the description. It's iocloudsystems at gmail.com.
Gmail.com, yeah.
Uh, iocloudsystems at gmail.com. I'll put
Yeah.
that in
I
the,
believe that
I'll
there's a
pin
link.
that.
There's in all the articles mention it as well. So
Perfect. I'll put the Medium article link as well.
perfect.
Perfect. And with the closure, Spider, I appreciate if you can expose some of your musical talents
I don't
to the
know.
world, and then please, don't blame me if you're getting more requests for composing more music.
No,
So
you
that
know,
Spider
sometimes,
Campos, everybody.
yeah, I sometimes decompress. Even during a meeting, I might turn my mic off, and I just, you know,
Yeah, amazing. Go for it. You want to turn up the volume a little bit, or you want to
oh,
turn up the mic a little bit, or
the mic.
yeah, if you can.
Sure, I can. It's
Are you feeding it
that's
from
full.
your attach it in the end?
Yeah.
I'm recording again. So Spider, I think first of all, I wanted to thank you for the time and taking us through all of it, and forward to your music clip as well. And I think this is beautiful. I just wanted to give closing remarks on, like, I think there is great potential of how this library can make impact to businesses and developers. It's to me, it's a win-win. As a technologist, I realize that it's a win-win for developers who are writing code. They can just focus on it and deliver world-class code, and at the same time, better decision making for business owners and decision makers. So that is the potential is like unlimited, and how where we want to use it, DDD and everything. I think it's beautiful. So what you guys are doing is tremendous and terrific. I was glad we could have this conversation, and thanks for your time again, and appreciate it, man.
Thank you. And I just want to say one thing. Like I want to make a plug for my buddy Adam Dymitruk. Adam is the inventor of event modeling, and to me, it's one of the greatest paradigms since event sourcing. Event modeling is a fantastic way. Like it beats C4 and you have and ROP and all of that by a mile. It's not no comparison. In terms of modeling the business logic, check out event modeling by Adam Dymitruk, Dymitruk.
Yeah,
He's awesome. Event modeling.
he is. Yeah, I know him. Yeah,
Event modeling
Adam.
changed my life. I think
Yeah,
it's really, if you haven't heard of it, check it out. Go to Adam's site. It's
yeah.
just a fantastic tool. And it's a great pairing with VESA, with the
I know,
library. Yeah,
I know. JP got us into Adam. I think
yeah, yeah.
JP got us into Adam. So Jean Paul, Sylvian, Boodhoo. Thank you, JP, for
Thank you,
introducing us
JP.
to. Thank you, introducing us to event modeling and Adam. He's fantastic. His session was amazing. I think we all enjoyed his event modeling session. It is amazing for businesses to take a look at it. Yeah, I will tag event modeling as well. And yeah, man, thank you so much.
You're
Appreciate
welcome. My
the time.
pleasure. My pleasure.
Okay, take care.
Thank
Bye
you,
bye.
DJ. Bye bye.
Bye bye.